right, so petroleum as an energy source. Whoa, too far. Okay. So the definition of energy is our ability to do work on a system to measure that energy. We have two types in general, kinetic and potential. There's definitely subcategories that we're going to go through right now. And then there's other types of energy. I don't know as well. We're really going to focus on the two main, kinetic and potential, and then they're like subcategories. So we tend to think of kinetic energy as movement. So when particles are moving, potential energy is stored energy, which is kind of what you see in that table there. So kinetic we think of as motion, heat or thermal energy, that's movement of molecules. So we do think of that as kinetic. Sound, that's again movement of particles. A sound is transferred because one molecule like hits the next and passes it on. So kinetic. Radiation, that whether you think of particles or light like waves, it's still movement. And then electrical is the movement of electrons in electricity. Potential energy, gravitational, if you hold something in the air, it has the potential to fall because of gravity. So gravitational energy is potential. Chemical energy, when you have two reactants, putting them into products is going to be potential energy. Those two chemicals have the potential to be something else, right? Potential energy. Stored, which is kind of what I said is the definition. That's what we think about as the most basic one. So like a spring, we can compress a spring and there's stored energy. When we let it go, we know it's going to pop up. And then nuclear, same thing with chemical. Nuclear, that's a reaction that can happen. So again, having the nuclear components, it has potential energy ready to change into something else. So when you look at this picture, I'm asking you to identify the different forms. You might want to pause it here and see if you can do it. And once you've seen if you could do it, you can check out the answers in the next slide. If you want to do it with me, you can. So A is pointing at that light bulb. That's electrical energy. B is pointing at those cups of coffee. That's thermal. C is pointing at the X-ray. So we consider that radiation. Whereas D is the frisbee in the air. So we consider that motion, just general motion, kinetic energy. E is pointing at the sun. So that could be radiation because the radiation is what's coming down to the earth. Some people might say heat too because you feel heat. You feel heat because of radiation. So either of those answers would be acceptable for the purposes of what we're doing. F is potential energy, kind of like the same thing as a spring. Once you compress it, you know when it's going to like pop back open. In F, he's going to hit that ball. So while he's still, he has potential energy. And then when he's in motion, it's kinetic. So that's stored potential energy. And then G is eating that ice cream. So I would consider that chemical because of the digestion process. Just as a review, those are all of the answers that I just said. Again, if you want to pause that and record that in your notes. All right. Energy conversions. This picture is sort of a web of all of the energy conversions. Not possible, but just some like general ones, how you can see that up here with these like barrels of, you can see like the little yellow sign is like toxic. It just means chemicals. We can convert that to electrical energy. It can be converted to mechanical energy. So for instance, chemicals can make electricity or it can make something move. Both. If we went all the way from kinetic to chemical to electrical to kinetic, it can go directly to kinetic. The electricity can turn into light or sound, or both. So there's sort of like a web of energy conversions there. So just because you have one type doesn't mean you can't switch between them. You can also switch between kinetic and potential. So that's what you see there in that diagram. Again, pause it here if you need to fill in any of those blanks. So talking about the specific conversions in this car. I know it doesn't look like a car, but like the basic car. You first have the gasoline tank, which would be chemical energy, right? That's stored energy, chemical energy. You turn it on, it changes into mechanical energy because it makes that piston go up and down, which is mechanical energy also with that crankshaft because that kind of turns in circles. And then kinetic energy with those wheels, they turn and they move that car forward. So the car then has kinetic energy. So just like in a single car, we can see how petroleum can go through many different energy conversions. Energy efficiency. So when we do like mathematic equations, we assume 100% efficiency, but in reality, that's just not true. As a matter of fact, in most, for example, cars, like 75% of the energy that's transferred in all of those little transfer points is lost to the environment as heat. So that's why if you're driving for a long time and then you stop and you like touch the hood of your car, sometimes it's kind of hot. If you open the hood of your car and you touch the engine's going to be really hot. That's because all of the energy from those reactions is being released as heat. Therefore, 25% is what gets transferred on like through the process of the energy transfers. Here's an example calculation on page 245, numbers 1 through 4 in your notebook. You're going to do those based off of this calculation, but I just wanted to show you when it says that you assume your family drives 225 miles each week, that's a conversion factor. You see that conversion factor here where 225 miles we put over 1 week. You could also flip that. You could say in 1 week we do 225 miles, same thing. So you could flip that either direction. It gave you another one because it says that you can go 23 miles on 1 gallon of gas. So we have another conversion factor. So you see it written both ways, sort of as expressions here. And then down at the very bottom here, I showed you specifically how to calculate it, right? We would take that 225 miles. We would say 23 miles is 1 gallon. So we divide by 23 to get our 1 gallon. And then we want to know how far that car goes in 1 year. Well, we know that in 1 year, we have 52 weeks. And remember that first conversion was miles per week. So that 1 week we convert to, or the 1 week we convert to 1 year by multiplying it by 52. Then we get 509 gallons per year. You should follow that same process when completing 1 through 4. So please have this slide up maybe while you do that. I think that's going to help you. When you've answered those questions 1 through 4, you need to finish up the rest of that outline. It's in the book starting on page 252 and continuing through 256. Please let me know if you have any questions. Totally happy to do some live calculations for you. Just ask either in the discussion board or in class. Thanks, guys.